On Friday, we discussed where these formulas came from. We showcased a brief proof out of all of these formulas, on the top list at least. The bottom list is a weird one because you kind of work the top ones backwards. It's actually kind of fun, but it's a pain to show without some extra examples, and so we'll leave it as just accept the bottom ones as they are. Today we're going to talk about two big types. How to use it when you are given some specific piece of information, and how to use it when you're given a general expression. So examples. The easiest kinds of your homework for this week are going to be as follows. Given sine of 6x, find a reduced version of the formula. So, you're asked to reduce this expression. What that means is find a way to rewrite this expression in another form using alternative trigonometric functions. Now, in this specific example, we have sine of 6x. The trick with this week is being able to look at a formula and recognizing that it fits one of the already pre-established modes. 6x is not just 6x. We can think of it in alternative ways. You can think of it as things like 8x minus 2x and use difference rules from last week. You can think of it as 2 times 3x and use the double angle rules from this week. You could think of it as half of 12x and use the bottom set of formulas. There are a lot of ways to approach these kinds of problems. I cannot express that enough. For these kinds of systems, all the formulas you have allow you to rewrite or reduce or change in some form. Your job is to figure out which one you think matches the best mold and how to do it. So for this problem, as a reminder, based on the rules we've talked about so far from last week, we could rewrite this as sine of 3x plus 3x, or sine of 2x plus 4x, and use a sum rule from last week. We could use a difference rule from last week and do sine of 8x minus 2x and do a difference rule instead. But we're going to focus on primarily this week's material, looking at double and half angles. So we're actually going to get two versions of this problem to talk about. One that is a variation that is going to be using the half angle. One is variation going to be using the double angle. What's weird to note about these is the name feels kind of backwards. Because the double angle formula wants a doubled angle inside. The half angle formula wants a half angle inside. And so let's take a look. So again, as a reminder, these three we could all do from last week. They are totally reasonable things. Now it's weird to do because we talked about how you have to rethink algebra because you only want to put things together, but this is just taking it apart. But from this week, let's talk about the two ways we could approach it using half and doubles. So, one way to rewrite sine of 6x is we write it as a doubled angle. Now in this case, 6x needs to stay 6x. So when we simplify it, the result needs to be a 6x. But how we simplify it matters a lot. To write as a double angle, we would do sine of 2 times 3x. Notice that this puts it in the form of the double angle formula. That's good. I can now use this top formula to do the math to get to the solution. Notice what it did, though, is kind of opposite the name. It's called the double angle formula, but look what happened to the angle inside. It got split into 2 and 3x. Feels like it cut it in half. And the result will have a 3x in it. Feels like it's half as big. So to me, it's always felt weird that the double angle formula doesn't double the angle. It wants to use the double angle. Which is actually cut in half. The half angle formula works awesome. So notice the half angle wants to write it as alpha over 2. So if I want to use the half angle formula, the way I write it, I would do sine of 12x over 2. Notice that both of these simplify back to 6x. And give wildly different solutions if you're looking at the examples on the formulas. In the end, I will graph all three of them. and so they're all the same. You are asked to do this by hand. This is to find the three different versions. The original version, which is given to you, and the alternate versions. Some problems in your homework will say, find the double angle version. That means do it the top way. Some will say, find the half angle version. That means do it the bottom way. Here we go. Top way. Okay. So what I do, just like with last week, I have a pre-described list of formulas that are guaranteed to work. We proved they worked on Friday. To do so, all I have to do is figure out which piece is my alpha, plug that piece into my formula, and have my solution. So in this case, sine of 2 times 3x, 3x. Like I said, that always frustrates me because it feels backwards, right? But notice that how I define it is what's inside. Is inside something doubled? 2 times 3x, that's doubled. You're doubling the 3x. Or is it cutting it in half? This is half of 12x. And so how you do it and how it's described feel kind of opposite. That has always frustrated me. I care that you can use the formula well. That's what I care about.
So the top one would be considered half.
Top one's double because notice what's inside of it. I am doubling a 3x to get to my 6x. Whereas the bottom one, I am halving my 12x to get to the 6x. So let me put that on here. This one is the double angle. So do the problem once as a double angle problem. And the bottom one is a half angle. Again, it has always frustrated me, the same thing you're asking me, Aiden. Because it does feel like it should have been labeled backwards. I have people ask me, you build a time machine and like slap somebody. Whoever named these, like, I get why they did it, but like, come on, man. Like, could you come up with a better name? Just call it after yourself. This guy was named double angle, in which case, kill your parents. So let's take the top one. We're going to rewrite it using this top set of formulas for the double angle formula. So notice that again, in this case, I have 2 theta as my base. So in this case, my 3x is my 2 times theta. So my result is the following formula. 2 sine of my theta value, so sine of 3x, times cosine 3x. This is my alternate way of writing sine of 6x.
Is this simplified?
That's simplified. So what we've done is we've reduced the angle inside. It went from 6x to 3x.
And could you leave it as sine of 2 times 3x? Because that's reduced from 6x.
Yeah, I know.
I hate this.
I understand.
Stupid.
So, the idea is to generate a new solution that has a different form. A different way of writing it. So, in this case, my sine of 6x becomes 2 sine of 3x goes into 3x. And when I graph these, they should be the same. Alright, using the half angle formula. So in this case, I have 12 over 2x. Again, that simplifies right back to 6x. It follows the same basic format. And so for this problem, I would have my alpha over 2. In this case, my alpha is the 12x. So I go to this formula. I plug in to this sine formula the square root of 1 minus cosine alpha over 2. This becomes plus or minus square root of 1 minus cosine alpha, so cosine of 12x all over 2. Both of them came from our formulas. Yes, in both of them.
So those are
Yep, they're on the cheat sheet. Okay. These are all the formulas we're going to use today. Yep. So you see the process, the only tricky part about it is making sure to have the right 2 values in them. So making sure you have 2 times 3x to replace 6x or 12x over 2 to replace the 6x. That is kind of the most annoying part about this. The rest is plug and play into a formula for this part. These tend to be the easiest ones. So let's take our function, and before we try another example, I want to show that these 3 are in fact the same. So let's take a look at the first one, which is sine of 6x. Let's see. We'll do the second one, and then we'll plug in the third one and see what happens. Here we go. In theory, as we mentioned, all of these should be the exact same function. When graphed, it should do the exact same properties. So we have the first one, sine of 6x. As a reminder of what we talked about back in chapter 7 and chapter 8, when we were graphing these things, the 6x will change the period of our function, making it go by quickly. Beautiful. All right, our second version was 2 times sine 3x cosine 3x. This should be the same graph according to our functional rules. Let's graph it. 2 sine of 3x cosine of 3x. Oops. Go away. Cosine 3x. Look at that. Same function, just written different way. The third one, you'll notice has a plus or minus in it because depending on which quadrant the original function was in, it can do slightly different things. And so I'll draw the first one and see if it's right. If not, I'll put the negative in, and that should be the correct solution instead. Here we go. So it was square root of a fraction 1 minus cosine of 12x all over 2. So this function, you notice, gave me a modified version. It doesn't perfectly match. Let's try looking at some of the negatives. So what I want to point out is parts of it match, but other pieces do not perfectly match up. So in this case, the pieces that don't perfectly match are ones that are negative versions of the ones that do. So right here, zoom in on one small portion. It matches perfectly right here. This first piece matches beautifully. But down here, notice that it just wants the negative version of it. That's why there's a plus or minus in the formula. Is because parts of it will match perfectly, parts of it will be the negative version of it. You have to be very careful with the second set of formulas, these half angles. Usually they will give an indication as to which part you want in the problem itself. We'll some more problems tomorrow I'll talk about. But again, notice that it's just a variation on the original formula. It has every piece right, it's just whether it's positive or negative that matters. That's why there's a positive and negative in the solution. Next, same process. New problem. We're going to rewrite a cosine function. We'll rewrite once with double and once with a half. Cosine of 3x. We're going to rewrite once using the double angle, once using the half angle. Now, what I want to point out with the cosine function is there are 3 different versions of the answer. So the question becomes, which one? Usually you go with the top one. It's very rare to use the other 2 unless the problem specifically says to use them. Like it might say something like, hey, write it specifically in terms of sine. Then you want to use the second version. I might say write it specifically in terms of cosine. Then you want to use the third version. Otherwise, you'll mainly use the top version for everything. So, let's rewrite this function. To do so, remember, we have to find a way to turn it into a doubled angle and find a way to turn it into a half angle. This is modifying the number inside to rewrite it as a new function. This becomes 2 separate problems. All right, here we go. First one.
1 or 2 times 1.5.
Beautiful.
X.
So we rewrite cosine of 3x as 2 times 1.5x. 3 halves also works. Or cosine of 2 times 3 halves x. because both of them will multiply back to 3x. So we know both of them should be theoretically correct. Now, they'll give slightly different looking answers, but they should be the same solution in the long term. What I like to judge this on is, if I'm going to have to check this with a calculator, which one is easier for me to type in? And that's kind of personal preference. If you're fine with the fraction button and you have a nice fraction button on the calculator, you might like the second one a lot. Me, personally, I use a TI and the fraction button is terrible. It's awful. It rarely works. And so I'd probably use 1.5 because I think it's better. Makes my life easier, that's for sure. So pick the one that you like better and do it. So let's do this. We've gotten our function to be written as a double angle. So again, the angle itself was cut in half because it's writing it as an angle that is being doubled. 2 times 1.5 does get me back to 3x. So 1.5 is the doubled angle. I plug it in. So again, in general, use the first one unless it specifically says write it in terms of sine, or it specifically says write it in terms of cosine. Here we go. The top one would become cosine squared of my number, which is 1.5x, minus sine squared of my number, which would be 1.5x. That is one solution. If you wrote it the way Madeline suggested instead, it's again the same answer. Looks a little different. In both cases, my angle that I have in the problem doubles to become the angle I had originally. So 1.5 doubles to become the 3. When I type this in up here, I find doing fractions on decimals to be annoying, so I will use a decimal. Again, it's personal preference and calculator work. Alright, how to do it as a half angle now. Again, similar process before. This time we're looking for an angle that, when I cut it in half, gets back to 3x. Again, it feels a little backwards, so what do you guys think?
6x over 2.
Cosine of 6x over 2. Beautiful. So, what I'll do, notice that the nice thing with the half angle formulas is they're very, very similar to each other, but that means I gotta have them well remembered here when I use them. Cosine of 6x over 2. That's right. Equals. This would be the square root, or plus or minus, the square root of 1 plus cosine of 6x all over 2.
I don't like the half angles. Feel like it's overcomplicated.
But the cool thing again is that all these have the same solutions as the original problem, so it's just a different way of writing it. And depending on the needs of the system you're working in, I talk a lot about using these with computers because it is the main application of them. Some of them do a squared formula much easier than an original formula because of how the computers are set up. And so you may want to look at this version of the problem when considering this problem. Other times, you may be like, hey, this computer works really well with a square root function. It has great possibilities to work very cleanly with it. You can do them quickly. So you probably want to use the second version instead. Like, there's so many ways you could possibly do it. Most efficient one can do it. So, as a reminder, we could always go back to last week and rewrite 3x as x plus 2x. And use a sum difference formula. And get another version of this problem. We could write it as 5x minus 2x. And get back to 3x that way. And do a difference problem instead. There are so many things you can do with these problems. You just got to make sure you do it correctly with what you want to do. So, in all the problems this week, all the homework problems that says specifically either use a half angle or use a double angle, make sure to use the one you're supposed to do. Let's check to make sure these are correct. So I'll graph cosine of 3x, I'll graph cosine squared of 1.5x minus sine squared of 1.5x, and I'll graph the bottom one. And let's make sure it's all the same. Desmos, come here. Come here, Desmos. So, first one is cosine of 3x. So again, this is taking the cosine function and changing the period of it. Oh, cosine of 3x, not squared. Look at that. So, beautiful. Now, as a reminder, the third one, the half angle one, has a plus or minus. So it will not match perfectly. Parts of it will match perfectly. Other halves will be negative versions of the ones we get. So we have cosine squared of 1.5 x minus sine squared of 1.5x. All right. Look at that. They match perfectly. By George, we've done it. Yep. So this one will match perfectly on the tops. It'll match perfectly. On the bottoms, though, it'll need a negative version to flip it. That's why it includes the plus or minus. Okay, so know that if you graph the half angle ones, they will rarely match perfectly because of that square root. Remember, square roots do not work with negative values to get imaginary numbers. That's why we have the plus and minus. All right, this last one is big square root of the fraction. Let's see, it's 1 plus cosine of 6x all over 2. And so see, the tops match perfectly, and then there's middle pieces that would need to be negative for it to work properly. And so that's why the plus or minus is there. All right, so the first part of your homework, it is, in my opinion, part of the easiest part. Again, the formulas are not hard to use, it's just figuring out which one you can plug them in. And once you got that number, plugging it in is easy. Just make sure you check your work when you're done. Let's talk about the second part. The second part is also pretty straightforward.
Can I do a tangent one?
Oh, you want to change one too? Yeah, of course.
God, cool. Just on the
Yeah.
half angle, I don't see that.
You don't need the double angle?
All you do is plug it in.
Okay, yeah. So let's do tangent of 10x. Okay. So the double angle, I'll go through it quick since Cole says he's already got it. I want to make sure everybody at least sees it. The double angle would become tangent of 2 times 5x. Which should I plug in? Dang it, Ford, stop doing that. Equals, let's see, 2 times tangent of my number, which is 5x, all over 1 minus tangent squared of 5x. The half angle would become tangent of 20x over 2. Again, make sure whenever you find your second one that it does simplify back to the first one. 20 over 2 does simplify back to 10. That's how I know I've got a good half angle formula. From here, now I plug in 20 into this equation. Again, in general, the top one is the main one. The only difference between them is which one you prefer. I think the other two are better, I'll be honest. Mainly because if you look at the other two, there's no plus or minus symbol. So you consistently get better answers. For some reason, the book emphasizes the first one, so I will do the same. Okay? Make sure to read your directions. If it says to write it more than one way, then just know that the other one's the option. Okay? This will become, this is plus or minus, square root of 1 minus cosine of 20x all over 1 plus cosine of 20x. Alternatively, the middle version would be sine of 20x over 1 plus cosine of 20x. And the bottom one would be 1 minus cosine of 20x over sine of 20x.
Do we have to do all three of them?
No. Those are the two that I expect to see homework. Those are the two that the book recommends. Now again, personally, I like these two better because there's no plus or minus. They tend to graph nicer. But the book tends to focus on the first one, so I will follow suit like a good little boy. Now again, all of these should be the same as tangent of 10x. In a second, I will graph these and see what happens.
So,
Yes,
you
Amy?
would simplify it in order, you would always simplify it?
No, the nice thing is these formulas are pre-simplified. So that is your solution. Yep. Let me grab it to make sure it is right. All right, these are fun. Tangent 1 is always fun. Let's go to Desmos. Come here, Desmos. You beautiful, beautiful baby. All right. My original equation was tangent of 10x. So tangent 10x. Okay. So first of all, that's kind of cool. But you know, it's tangent. All right. My first variation is that one. 2. Sorry. Division problem. 2 of tangent 5x all over 1 minus tangent squared of 5x. Yeah, that matches perfect. Must be done something right. Alright, now again, I'm going to showcase the one we use, the top version down here. But again, I like the other two more because they will perfectly match, whereas the other one, you'll notice, does not perfectly match. Here we go. Big square root with a fraction inside. We have on top 1 minus cosine of x, so cosine of 20. And on bottom, 1 plus cosine of 20. So notice again, part of it matches perfectly, but the other part is just a negative version problem. It's not quite perfect. So again, I am not a huge fan of this variation. I prefer second option or third option. And they do work well. Take a look. The third option, so that would be sine of 5x. Sorry, sine of 20x. Come on. Oh, don't film me today. Not today.
No.
Oh, please.
Dude, I'm early, man.
Do you believe me that the other one works?
No.
No.
Yes.
It's kind of good for today, though. I think more time.
The board's like, no more math, please, sir. The kids got on Oliver. 1 plus.
Hey.
Good mix.
How are we facing today? It's better than the kid we saw Saturday. Ethan? Brumman? Did he throw against us at the game or no? He's their shortstop. He's going to Ozark. Is he decent?
Come on.
Come on, dog.
That's literally the biggest bets I've ever seen.
It is?
Biggest one I've seen.
Oh, this was the tweaks.
That should be wrong.
The thing was massive.
But like in person, I can put my whole fist in his mouth.
Yeah, Logan said he could put his fist in it.
And I got a big fist.
Like I said, I prefer option 2 and option 3 because they do perfectly match. Again, the top option matches, just it has that plus or minus which causes some issues. I like option 2 and option 3 much better because they avoid those issues. Okay. Now, I'll finish off today talking about the same thing we talked about last week, which is if we don't have the actual value itself, how to still use these formulas. We'll work through tomorrow a bunch of examples with this stuff, but I want to get through at least the instruction part for today, that way you have that before we begin tomorrow. Okay.
Get off me, baseball.
Here we go. Come on, board, please. Begging you. Board.
Yeah, I want that.
Constipated.
No.
It's okay, it happens to best.
Oh,
That's good to know there.
There's only so much cheese.
I think we just call it good.
Okay.
why is that not smooth?
So then, as a reminder from last week, we talked about for the ones that do not have a specific angle, if there was a way to do it. Thank you. It involves 4 steps. These 4 steps, when I say them, they'll sound familiar. These are the 4 steps we are following through on tomorrow. Here we go. Step 1. We will start by drawing a picture. Drawing a basic triangle that describes what the problem says. Step 2. We will determine which formula is the correct formula. Okay. Step 3. We will find the actual values using the formula and the triangle. And finally, the last step, we will simplify. So again, for tomorrow, I guess this will be the last part of our notes today because this is kind of acting up. Step 1. We will draw a triangle. We have to draw a triangle with what is given to us in the problem. So the problem says tangent is equal to some fraction. We have to use that to draw the triangle. So it'll involve remembering what each of the trig functions means and remembering how to put that into our picture. Step 2. Once we've drawn the triangle, we'll then need to find the correct formula. It doesn't say this in the book, but I know it's going to come up. Step 2, we'll use Pythagorean's theorem. Guaranteed. Remember, every trig function that's up here uses another trig function to get the answer. So if I have to use the third formula up here for tangent, it's the only one that keeps using tangent, but it's tangent of a new value. So, everything else, sine uses both sine and cosine. Cosine uses both cosine and sine. Or it could use other ones. Like, there's so many that you could use. It's best to use Pythagorean's theorem to help finish your triangle.
This is natural 3,
Correct. 3. With that information, well then, 1, 2, determine the correct formula.
Oh, you messed me up, man. You said find correct formula is number 2.
I did. You could put draw triangle and Pythagorean theorem together, because those two are going to go together every time. And finally, step 4. Where I want to simplify. Or should I say, plug in and simplify.
This guy's too simple.
That's what we're doing tomorrow.
What are these rules for?
Oh, these will be specifically if you're given a trig ratio. So, in the homework tonight, we haven't gotten to that part yet. We'll work through a bunch of examples tomorrow.
Would it be drawn given trig ratio?
We want to see a problem that's going to be like number 9, 20, 21, problems like those. The ones where you're given a trig ratio and you have to find a new one. So we've done that a few times before, but these have been the same things just every time. By the way, for future reference, these are great trig steps in general. Like, if you're not sure what to do, this is a good place to start. Draw a triangle, use Pythagorean's theorem, and then see if you can find a formula from there. In? Good. That'll be it. Any questions so far on the double and half angle formulas? There are a couple questions in the homework that use the half angles specifically. They're the ones like finding sine at 15 degrees. So it's very similar to what we talked about in the first section. Let me go ahead and pause the recording.